take notes there, Emily?
Yeah.
Oh, wait, perfect. Thank you so much, kid.
I'm an idiot, but at the same time.
All right, hey, how about the chances you guys, did we get through example 3 yesterday? Using synthetic division?
Yeah.
Okay, and this isn't going to take very long to get through today, kids, so I got one last example after this one. But kids, yesterday we had this idea of synthetic division for dividing polynomials. We said we can divide polynomials by the form of x minus what, kids?
Okay.
All right. I can use synthetic division for this first example, or I should say example 2 right here, because this is in the form of x minus 2. So what did we use as the k value here, kids? In example 2, what was our k value for that yesterday? Positive 2. Okay, so it's kind of the opposite of this negative 2 right here. What do we use for k down here? Positive 1. So I think that we had a pretty good understanding of that yesterday when we left. Now, the last thing that we need to touch on today is this, kids. Last thing that we're going to talk about here, remainder theorem. All right, the remainder theorem is pretty cool. And I'm going to show you how this works. All right, remainder theorem says if a polynomial f of x is divided by some binomial of the form x minus k, then the remainder is r is going to equal f of k. So as an example, it says use synthetic division to do what, kids? Evaluate f of x. Okay. Now the old way we used to do this, kids, was this. And it's really not old. We're going to continue to do it as the year progresses. But if I wanted to evaluate f of negative 2, you would say, hey, Parson, take negative 2 and throw it in for what? Let's try that. Let's see what we get. If I wanted to evaluate this function right here when f of x, or when x is equal to negative 2, we would say f of negative 2 equals... All right, you guys are going to help me because my mathematics brain is kind of slow today, like the internet around here. Okay, check this out, kids. I need some help. This part right here, what's the negative 2 cubed here? What's negative 2 cubed? All good?
Thank you, Parson.
You're welcome, kids. You guys are the best. You guys are the best. You deserve it. Okay? Negative 2 cubed was negative 8.
You deserve a truckload of sour patch kids.
Next time, right? That'd be awesome.
Did you win the lottery? A Chevy truckload. You didn't? Did any of your numbers?
I didn't even get a single number right, I don't think.
I was talking to Rosie about that yesterday. Rosie said you're a really nice guy, Parson.
Who?
Rosie. She's a daycare person advisor at the Playhouse. She says she knows your wife.
Oh, really?
Yeah.
Yeah. She said I was a good guy. Well,
She said she really likes you.
there's at least one liar in the world. I'm just kidding. Well, tell her I said thank you. I appreciate that.
I will.
I appreciate that. Yeah, Sam?
Can I go to the bathroom?
Yep. You gonna make it?
Wait. I kind of forgot about it.
Okay, you said that this was going to be negative 8 right here. We'll get through this here. Negative 8 times 4, kids. Okay, what's negative 2 squared? 4. 4 times negative 2 would be minus 8, wouldn't it, kids? How about the negative 5 and negative 2 times together?
10.
So this would be plus 10 and plus what? What's that equal when we evaluate that? What's that equal when that is all put together? This equals negative 19, you bet. So if I said, hey, evaluate that polynomial function for x equal negative 2, you could simply put negative 2 in and get negative 19. But what's going to be kind of new for you today is this. It's kind of going to stem off of what we've been doing with this synthetic division stuff. Okay? Turns out we can use synthetic division to evaluate polynomial functions. And the remainder theorem says whatever your remainder is in the end is going to be the evaluation for that particular value. So in other words, We were trying to evaluate this function when x was what value, kids?
-3.
Check this out. Let's treat the value I'm plugging in here, -2. Let's box that -2 like we did with synthetic division. Okay. Now, take a look at your polynomial function, kids. What's the highest degree?
3.
Okay. So what's the coefficient for degree 3 to start with?
4.
Okay. Do we know our degree 2 term then as I work my way down? Okay, the degree 2 term would be what value? Okay, and I should probably say the degree 2 coefficient. How about the degree 1 coefficient? Do we know that? Now again, if we don't see one up there, you have to assume what value?
0.
Okay, so what are you going to plug in next after the -2? And then is our constant up there? Okay, check this out. This is pretty cool. Same process. You guys remember it from yesterday?
Yes, I got it. Bring the 4 down.
Bring the 4 down. Who's talking me through this right now?
Bring down 4. And
Okay.
then 4 times -2, right?
Yep, 4 times -2 would be
-8.
-8. And I want to do this real quickly, kids. I'm going to go back into this. You know, some kids first and fifth hour got a little confused in this. Some kids are still subtracting columns, but when we do this synthetically, what do you actually do with the columns? Maybe it would help you to put a plus sign right there. All right? Okay, I'm listening, KB.
Okay, so then okay, you got that. So then -2 plus -8 is -10. Then -10 times -2 is 20. And then that's 15. 15 times -2 is -30. And -30 plus 11 is -20. Oh, 19. -19.
How does that match, or how does that compare to what we thought the answer might be? The remainder rate here was what, kids? -19, and -19 was our evaluation, right? Turns out you can use synthetic division to evaluate polynomial functions like that now, okay? So instead of saying, this is something, then times that, and I got to bank this, and this is something, I got to bank this, you can just go through this whole process, and that last number is your evaluation. So let's have you try one on your own. Let's go evaluate. Oh, I'm going to try and trick you. Is that okay? See what you come up with there. Got to be careful on this when you start this out synthetically. Can I just throw a 3 and a 2 and a -6 up right away?
No.
No? Okay. Anybody have an answer yet? Jasmine, what'd you get, kid?
I got
50? 50? 50?
That's
Anybody else
right.
50?
Yep.
Who else is 50? I'm not, I'm 43. Anybody want to talk me through this? We can use synthetic division to evaluate polynomial functions using synthetic division. Kids, help me. I need help. What are we boxing? 2. All right. Looks like I've got a degree 4 function, so the coefficient of degree 4 is what? Okay, what's next? A 2? Why 0? Yeah, there's no third degree term up here, so we've got to put a 0 in here. Now, how about my second degree term? 2. How about my first degree term? 0. And then finally my constant, what? Okay. Oh, I really screwed that line up. I better put it down further. All right, who's going to number me up here? Come on, Jasmine, go ahead, buddy.
So you bring the 3 down.
All right.
And you multiply the 3 by the 2, you get 6.
Okay.
And then 6 and 0, you get 6. Multiply that by 2, you get 12. Add the 2, you get 14. Multiply 14 by 2, you get 28. And then that equals 28. And then multiply 28 times 2, you get 56. And then subtract the 6 and the 56, and you get 8.
So if I plugged 2 in everywhere where there was an X up here, think they can hear it? What do you give me to go yeehaw if they turn it back on again? If I plug 2 in where X is up there in that function, what am I going to get out? 50. Betcha. How many had 50 there? Where did 28 come from, kids? Sam, I took the 14 times what? 2, and that moves me to my next value right up here, okay? And we're always doing what with these columns, kids? Always adding them up, all right? Well, that's getting kind of ugly up there. So we're always adding. You okay with that, kiddo? All right. Questions, kids, at all?